All right, so I'm going to talk about HTC facilitation for researchers on your campus, how you can identify, talk with researchers who have HTC-able problems, and point them to the Open Science Grid. I will also talk about the set of services that are available to campuses and staff like yourself who support researchers and research computing in any way. So we'll talk about how to break down and facilitate research problems that can be accelerated with an HTC approach and on OSG's resources, like I mentioned. We'll compare ways that campus researchers can access the Open Science Grid. OSG Connect is our central service, but it's also possible that they could use a local access point. Some researchers on your campus may already be accessing OSG through an access point operated by a multi-institutional collaboration they're part of. Hopefully we'll leave you with the ability to develop a personal and campus strategy for facilitating researchers who can benefit from HTC and the Open Science Grid. So there's a little bit of homework here. And if you want to talk to us more about how to facilitate researchers on your campus or anything else we've talked about today, other services that I'll mention in this presentation, just a reminder that we have office hours for 3 hours tomorrow that will start with an overview of OSG services and then discussion rooms for each of several topics relevant to supporting dHTC on your campus. So first, let's talk about facilitating campus researchers who can benefit from HTC and the OSG, and then we'll talk about those services. First, I'd like to just review that high throughput computing as an approach, and therefore the Open Science Grid, presents challenges and opportunities to make a really big difference and truly accelerate work on your campus, even that may already be using an existing cluster, but that by running in a high throughput way or going to the Open Science Grid could be further accelerated. One of the sort of challenges in facilitating researchers with problems that are HTC-able is that a high throughput computing approach may be new to some of them. Many researchers start out on a laptop or a single server or on an HPC cluster where there are incentives to use internal parallelization or to try to use multiple cores on what may only be a single server. And there are tools in software like Python, MATLAB, et cetera, that do this and make it really easy to use all the resources on a single computer. But that may still be limiting users in terms of the overall throughput and even the research problems that they can tackle. OSG, of course, has unique job logistics. We talked a little bit about this. Data is transferred and or distributed across the Open Science Grid, so there's no shared file system like a laptop single server or perhaps a local HPC cluster has. Jobs can be interrupted, which is fine. If your jobs are relatively short and you've got lots of them, you may not care that some of them need a second or third try to finish, especially if you're able to run hundreds to thousands of them at the same time. And one of the nice things about the OSG environment and really the Condor scheduler in particular is that it truly centers around giving the user an ease for communicating, submitting and managing highly numerous jobs, up to even millions. And with all of this and the capacity of OSG can provide a really serious enhancement to the user's overall throughput. And like I said, their ability to tackle and even conceive of larger research problems. And it's very much the case that a single user being able to use hundreds or even thousands, up to 10,000 total cores simultaneously is really an everyday occurrence if their work can run as lots of single core jobs, laptop size, that are easily distributed and open. All right, so finding HTC workloads. We approach this like we do any of our facilitators, right? We facilitate researchers on our local campuses too. We approach this like we would any conversation about research computing. First, we ask the researcher about their research and how computing fits in. We ask about near-term bottlenecks, how they're running things now, what types of requirements they know that their computations need to the extent that they know them, but also what their experience is with skills relevant to large-scale computing, like have they used the command line before, have they logged into a server? Not that they have to have significant background in any of those, but it gives us a starting point to understand how much of a change or how much they might need to learn in order to truly benefit from what might be very significant and justifiable impacts to their projects. And then we like to push them on how much they'd like to run considering opportunities that maybe they haven't thought of before in terms of scale. And what this translates into is kind of a social engineering conversation with enough detail. The facilitator can present an if-then statement along the lines of, if you execute your work this way, which might require some tweaks to how you've coded things, logging into an OSG submission point or a high throughput computing system, and this much learning, given your background, you could achieve this much computing impact. And we find that when we've taken the time to understand where the researcher is coming from, both in terms of their background and prior experience, as well as what they have to gain, often learning the command line becomes not an insurmountable problem anymore if they know that they could run 100 times or 1,000 times more work versus, say, on their own laptop. And so Christina and I are going to role play a little case study here to kind of give you an example, because this can be really useful to sort of see in real time. So I'm going to jump a little bit just because of timing, but I've asked Christina about her research background. She's a neuroscientist in a lab that works with MRI scans and time series of what people's brains look like as they undergo different conditions. And she's got a project right now that's kind of outgrowing their local lab server shared by many people, where everybody's kind of looking at her work as sort of taking up too much of that server. So Christina, I understand that you have quite a bit of MRI data to process. How many pieces of data do you need to tackle, like number of participants, scans, et cetera?
Yeah, for our current project, we're working with a study that had 130 participants, and then they had 3 different scans done over time.
Okay. And right now you're processing these with a MATLAB script that you said fits them to a model.
Yeah.
How long do you know if it, can, first of all, can each participant and even each scan, if each participant has 3, can those be processed independently?
So the model has to run with each scan, but those are, so I can do just a few scans at a time, and they're all kind of just separate. I can run them one at a time if I want.
Okay, so you mentioned that right now you run with a MATLAB script that internally can use multiple cores, and your group is allowing you to use up to 8 of the cores on your server, leaving some for somebody else. So if you've got 130 participants, 3 scans a piece, just doing some math here, that's around, so that's 390. And you said that they can be done independently. So I'm calculating 390 of these. Do you know how long it takes to do one of them?
If I do all of them on the group server, it takes about 2 days.
Okay.
But sometimes I test them on my laptop first, and that probably takes like an hour.
For one participant scan?
For one participant scan, because I can do like 2 or 3 at once, but then I can't use my laptop for anything else.
Okay, so it's 1 hour per participant scan. You have 390 scans. So yeah, that makes sense that it would add up to about 2 days with 8 cores. All right. And do you think that your MATLAB code could be written where it just reads in the data from one participant scan, but you could give it a different participant each time?
Yeah, because I have it written to run in parallel on the server, but it basically just takes the list of data files. So I guess I could change that from a list of multiple files to one file.
Okay.
If I wanted to run things one at a time.
Okay, so it fits the model independently to each participant scan. Let's see. Do you think that you'll need to run this set of 390, 400 scans more than once? Or is it really just this one model? And
yeah, so this is what's taking a long time is we do want to try different variations in the model, or maybe even a whole different approach. I don't know how long that would take if I used like a completely different method, but yeah, right now it's like kind of 2 days between different trials because we have to wait for them to run.
So how many different models, if you were to repeat this, each time with a different model?
I don't know. It's because it'll keep changing, but maybe like 5 to 10 to start with.
Okay. Do you, maybe not for this project, but in the future, would you need to consider more participants, more scans, more data per scan,
Yeah,
like higher
this
time
particular
resolution?
study, we might get a few more scans, but we also might want to apply it to 1 or 2 other studies of a similar size. So yeah, I could see running this on similar data sets, at least, yeah, maybe 3 or 4 different ones.
Okay. So breaking from that scene, the next thing that I could do is then talk about what kind of throughput Christina and her group could get. And with scenarios playing off of what she mentioned in terms of a desire in the future to tackle even more participants. So it's not just about getting her work off of the group server right now, because taking up 2 whole days on 8 cores is going to be problematic. But let's do some math here. So she has 130 participants, 3 scans. I already did this work. It was 390 core hours, which takes 48 hours on 8 cores. That seems like it's, in her case, at least an inconvenience enough for their group. And let's say I had asked about per scan data, amount of RAM. This is starting to look really like an OSG-able and certainly a high throughputable approach, just because, or opportunity, just because she really can tackle each participant and scan independently, fitting it to the model to extract features that can be comparable across participants. And let's say that she wanted to do 4 different models, or 5 to 10, right? Now we're looking at a significant increase in how long that's going to take to tackle all this work if she wanted to do all of these models. And maybe she could do even more. But the reality is that on OSG, 1,500 core hours is easily tackleable in a day. That's really an afternoon, because with jobs of these size, she'd within an hour have hundreds of them running. So that's already a significant turnaround improvement. But I also asked about more participants, like maybe in the future they'd have 5 times as many, or be collaborating across sites, or maybe that's something they haven't been able to consider as much before. Even if we increased by 10 times additionally, and even if the data went up a little bit, we're still working in per job amounts of data and memory that will totally work in OSG. And so even if this was up to 100,000 core hours, that's still something that's tackleable in less than a week on OSG. Whereas if we were talking, 50 times, 5 times, 10 times, what she's already planning with these multiple models to do comparisons, that would take quite a bit longer on her lab server. And so it's not just that she'll have somewhat of a benefit right away going with a high throughput approach, but that there are new doors open in terms of the data resolution that she can collect and process, and the number of participants, assuming that there aren't other barriers there, like the ability to get more participants or to even store the data across all of these participants and data sets. That was a good example, but just kind of shifting, we'll circle back to some of these questions, but some of the things that we're hoping that you can start thinking about and then bugging us about to help you answer them is, what challenges do you anticipate in introducing researchers to the OSG or high throughput computing approaches generally? We've talked about some of those. What are the benefits to specifically supporting researchers with HTC type workflows and using a system like the OSG? Benefits that we've already discussed are larger research possibilities beyond just being able to compute their current work faster. What else beyond your current resources would you need to support researchers using HTC approaches and or the OSG? And I hope that what you'll come away with next is that the answer to that is not much, because you can send them to OSG Connect and our facilitators will carry out conversations just like what Christina and I demonstrated and help make sure that your researchers can get up and going with the practical aspects of job submission on the OSG, in addition to helping them sort of challenge their preconceived notions about scale of research problems they can tackle. But something that you might start thinking about now is, how would you communicate about the OSG and with whom? Maybe there are researchers that you could point our way. Maybe your campus would like to be even more involved and to do more HTC facilitation and support more HTC work locally even. So I'll talk a little bit about how to access OSG and what services
Lauren, there
are
were
available.
maybe 1 or 2 questions in the chat that I think you
Sure.
can touch on quickly.
Yes.
Which is using HTC with OSG in a course, and then comments about HIPAA or other regulation data.
Aha. So I want to talk about the course in just a little bit when I talk about OSG Connect, because we do support that. And in fact, if Jeremy Evert is still here, he recently, actually this semester, is running a course that uses OSG Connect. What was the second question?
HIPAA data.
HIPAA data. Aha. So that one's really quick and easy. In Christina's first presentation, she mentioned that the open science grid is good for HTC work that is distributable and open. And part of what we mean there is that the data can be open. The access points that we operate are in no way HIPAA compliant. More importantly, the compute tasks that you run in the open science grid as any user mean that your data will exist temporarily, even if just in memory, but often on disk, on a number of different clusters themselves, not necessarily or usually not HIPAA compliant. And so restrictively licensed software, restricted data are really just not suitable for the open science grid because of their security requirements. All right, moving on to services for campuses and the researchers. Something that we kind of hid from you in our simpler explanation in the first presentation about OSG is that it's really a grid made up of multiple virtual clusters or virtual pools. And these are associated with different research communities. So there are some fairly large multi-institutional collaborations like CMS and Atlas, who discovered the Higgs boson, that have infrastructure at multiple campuses and computational staff that operate their own pools in the open science grid. They're operating their own instances of OSG software with sites that contribute resources specifically for their research. Many of those sites also contribute generally to more open and shared resources in the open science pool or in the open science grid. But we call these different pools listed over here individually VOs in the past, if you've heard that term, or virtual organization. But really, there's sort of separate pools of resources available to researchers of different communities. When you or your users use the Open Science Grid Connect service, or OSG Connect, and the same goes for campus submit points, we have those going into a large shared resource called the Open Science Pool, previously referred to as the OSG VO, and I'm circling it over here. It's this green band in the usage on our main accounting page, Grok. And this is where the OSG Connect access points submit into, where smaller multi-institutional collaborations have access points submitting into, those collaborations that have not opted to run their own pool. Maybe they will someday, but they don't have to. And if you choose to operate a campus access point or submit point, it would also submit to the Open Science Pool. This is where resources contributed from CC Star campuses are typically oriented, and where there is sort of the greatest diversity of sites that are contributing resources. So it's a fairly large set. And by the way, if you're interested, you can go to our accounting page and see on the project accounting page of our Grok accounting system, which projects may already be running on the Open Science Grid that are primarily or sort of headquartered at your institution. Most of these are going to be single research groups that use OSG Connect, whereas the entire Dune collaboration, which is a large multi-institutional collaboration, shows up as one project, even though it represents a fairly large number of researchers. So this is what OSG does then. There are multiple pools, but what OSG does is create software built on HT Condor that does meta scheduling. It coordinates HT Condor access points and sources of computing capacity into pools. So each pool has its own instance of the OSG meta scheduling service running. The Open Science Pool, which, like I said, is what all OSG Connect and local campus access points submit into, is an instance of that technology that is operated by OSG for the greater community to use. And you can have a campus access point or use an OSG Connect access point. Those access points can also submit to local resources. So like Marone said, it's sort of like having one queue of all of your computational tasks or even a large workflow if that's what you want. And beyond collaborator clusters and nationally shared clusters that make up a good portion of the capacity in the open science pool, it's possible for users to also loop in allocations that they have on national computing resources, or to pull in resources from the cloud that they'd like to pay for that via Condor can be configured to run just their jobs. And so there are ways to get your campus started and to engage at multiple places within this diagram of what OSG offers in presenting a grid of pools as the open science grid. For one, we've certainly got learning opportunities like these, and you can point your researchers to OSG Connect, where our own facilitators will help your researchers get started, and you can co-facilitate alongside us if you'd like to, as even a way to learn how we do high throughput computing facilitation. Also available now, especially with funding through the PATH project, you can work with us and consult with our experts on how to build HTC facilitation and even local HTC systems that can integrate with OSG or not through local OSG submit points, but otherwise allows you to support HTC locally beyond or in addition to sending researchers to OSG Connect as a starting point. But you can send OSG Connect, you can send researchers to OSG Connect now and anytime. You yourselves can have accounts on OSG Connect. In fact, your training accounts can be extended to be full-time accounts after this training. And we'll follow up to confirm and let you know by what date you should talk to us to get those extended. Otherwise, you'll go through the same sort of onboarding process that any regular user does if and when you come back and want to use OSG Connect again after this training. But all new users meet with a research computing facilitator. We've got online documentation, periodic user trainings like this one to take advantage of there. And just to clarify, OSG Connect being NSF funded is an access point that is specifically available to researchers associated with US-based academic, government, or nonprofit organizations. So it's not, for example, available to like commercial users or users outside of the US, unless they are affiliated with or sort of collaborating with a US-based project. As part of building HTC capabilities on your campus, beyond sending researchers to OSG Connect, you can, like I said, join our RCFs in facilitating researchers that you send to us if you like. Just have them CC you and you can join in on all of the conversations, including that first meeting. If you'd like to go further, perhaps getting to the point where you might have your own local access point, you can do on-site shadowing at UW-Madison, which we can do virtually these days. And also, you can then learn more by doing. So you could pursue a local access point, as some campuses, some represented here, have done, and we'll still support you and make sure that the setup of that access point is configured appropriately, and that you can still pull in our RCFs for tricky cases if you need to. We've got the OSG research facilitation team that you met earlier, who help with all of these things. There will be an office hours room tomorrow specifically discussing local access points, but a local access point, like the login node that you'll use today and the hands-on if you do that, submits into the open science pool, but it's sort of like turning the OSG into a cluster available to your researchers where you provide all of the user support, but you don't have to administer the worker nodes, and you only have to administer portions, probably the parts that you want to control on the access point itself. So for example, you get to administer user authorization however you want. Sorry for that slide jump. We help you do the initial HT Condor administration and configuration and provide ongoing support for that. And you can also integrate local data storage for the home directories, And also there's the option of having your own data origin that ties into the Stash Cache infrastructure. And importantly, you do not have to share computing resources into OSG as a site in order to take advantage of any of the other services I've mentioned. They can be pursued independent of one another. Like I mentioned before, you can build local HTC capacity, and I'll jump over this to save time, but also because the office hours tomorrow includes a room just about this topic where you can talk to the HT Condor software suite developers, actually the lead and some others, if you're interested in talking about building local HTC capacity. And like I mentioned, you can share resources into OSG. Some of you had good questions about this. This, again, is independent of whether you can send researchers to OSG Connect or pursue a local access point. It's not quid pro quo, and you can pursue any of these services sort of a la carte. There's also going to be an office hours room about this particular topic tomorrow if you have questions, including detailed security or technical questions. So next steps, just kind of reviewing, and this is where we'll give you a little bit of homework to think about. So just review for yourself, what are the benefits to specifically supporting researchers with HTC type workflows, whether on local resources or to use OSG? How would you communicate about OSG and with whom, not just researchers perhaps on your campus, if you think that this is a worthwhile thing to do? Think about the challenges, what other resources you might need, like we mentioned before. And the one that I want to leave you with as a takeaway is to try to come up with at least one goal and one concrete action that you can take in the next month, even if it's just that you've got a researcher in mind that you think could benefit from OSG tremendously, and pointing them to OSG. So think about that, and that's kind of a good takeaway sort of homework exercise. There are a number of other learning opportunities, and I haven't even listed all of them here, but these are the ones that I think would be most valuable to campus staff. The OSG user documentation, which is what we use to support OSG Connect users, is really valuable in terms of getting started. There are YouTube videos with more in-depth introductions to things like using Condor and submitting jobs, both under the CHTC and PATH YouTube videos, including videos under PATH that are from our October dHTC campus workshop that focused in more detail on resource sharing. So feel free to check those out or to come to office hours tomorrow. Other meetings and conferences besides office hours tomorrow are the all hands meeting. Registration is open now for that. It's a great opportunity to just drop in as you can, even if you can't commit to the whole week. And the first 2 days are really valuable for campuses. That's where we talk about impact to researchers and impact to campuses. There are past Condor Week materials that are really valuable. And then you can catch us at a number of external conferences like RMAC and PERC, where we've done trainings just like this one. Oh, and I skipped the OSG user school. There are good materials there as well, kind of more of a holistic introduction or sort of in-depth really to high throughput computing, and applications for that will open in March. So don't forget that exercise. And please reach out to us to get help. If you're not sticking around for the hands-on, these are the ways to get in touch with us, and in particular, support at opensciencegrid.org is how you can direct any questions, or go to OSG Connect, sign up yourself, and point researchers to sign up. And with that, I'll hand it back to Christina.
Yeah, we had a break scheduled, but that was more to like give people time to connect. So if anyone has any quick questions for Lauren, who wants to pop those in the chat, we can take those now.
Otherwise, Christina, should people go ahead and log in to
Yes,
the login node for their OSG Connect access point? And that will be what you need to prepare for the exercises. And if you have any issues with that, you can drop them in the chat or speak up verbally, and we can try to help make sure that you're able to log in for the exercises.
Yep. So we'll pause there. Questions in the chat.